Hey everybody, I want to talk to you about air masses and fronts today. This is Mr. Bremberger here. Basically, we're going to start with air masses because without air masses, you cannot have fronts. Essentially, your air masses are out there. They're large, huge bodies of air that all have some similar characteristics that we're going to get into. And these air masses will literally bump around with one another like a huge set of global bumper cars. Looking at the United States here, we can have several different air masses kind of originate from a few different areas. If you take a look, we have some maritime polar air masses, we have some Arctic air masses, some continental tropical ones. But basically, break these different air masses apart, you need to first think about what or how they're classified. Those air masses are going to be classified by three things. Number one, their temperature. Two, the type of pressure they're associated with, as well as the third thing, which is humidity or their moisture. Your four different types of air masses or groupings can be sort of known as either continental or maritime. Those are going to have to do with how moist those air masses are. So if you have a really moist air mass, it is going to contain obviously a lot of water vapor, and those are going to be referred to as a maritime air mass. If you have a dry air mass, those are going to be referred to as continental air masses, because most of the time these air masses are going to obtain their moisture content or lack thereof based on where they originate. So if they originate over water or pick up a lot of water from either an ocean or a Great Lake, for example, those could turn into some maritime air masses. If they're dry, generally those are going to form over land, and obviously there isn't a whole lot of water on the land to speak of, so those air masses are going to be referred to as continental air masses. To go along with the moisture content, we also need to throw in a temperature sort of phrase to go along with those. So any warm air mass would be referred to as a tropical air mass. A polar or Arctic air masses are going to be generally your colder varieties. So again, tropical we are going to associate with warm, and polar or Arctic will be associated with cold. Now we do have the ability to combine these phrases together. So for example, let me change my pen color here. Maybe not. I'll just use my pointer. If we want to create a air mass or have an air mass that is dry and warm, so combining two different air masses here, and I apologize, we were just interrupted by a student. Combining the continental with the warmer region down here would give you a continental tropical air mass. To combine a cold dry air mass, you would have a continental for the dry and cold for the polar or Arctic, so you'd call that a continental polar or a continental Arctic. Same thing goes with the maritime. So if you have an air mass that has a lot of moisture, you're going to call that a maritime tropical if it's warm. So again, maritime tropical would be a warm, humid air mass. Or you could obviously have a maritime Arctic or a maritime polar air mass, which would obviously be cold and humid. Now, when these things collide, or play global bumper cars, when you have those different air masses that, for example, one might be cold and moist and the other might be warm and dry. You have those coming together, we're going to have a massive collision on our hands and an opportunity for some weather events. Now, that collision is literally referred to as a front. Now, there are several different kinds of fronts, and none of which contain soldiers of any kind. So we're not dealing with these sort of facts. We are dealing with these, which here are your weather symbols for the various types of fronts that we'll be getting into here today. Upper left-hand corner, you have what's going to be referred to as an occluded front. This one over here, which kind of got condensed down, is a stationary. You also have some cold front symbols and a warm front symbol. Moving into each of these, the cold front is a very specific kind that brings about a lot of significant weather events for us. So, looking at cold fronts and defining a cold front, what you actually have here is a cold air mass that will move into a warm air mass. Now, when the cold air moves in, sinks underneath the warm, that warm air rises, and generally there's going to be a little bit more moisture associated with the warm air because it has the ability to evaporate more. And when the water vapor rises, obviously we'll get some condensation to occur, or cloud formation. And right along the edge of that front will create generally some potential for severe weather, or definitely precipitation. Warm air masses, when the warm air mass runs into the cold air mass, it kind of just slides over the top of it, creating some longer periods of rain or showers. Because again, your warm air mass is going to have generally a little bit more moisture associated with it. So, and because the warm air mass is moving into your cold air mass, we're going to have that warm front occur. So, kind of comparing and contrasting your warm and cold fronts. The cold fronts are obviously called cold because you have the cold air moving into the warm. Vice versa with the warm air front, or the warm front. The warm air will be moving into the cold. So whatever your label is going to be kind of the global bully, so to speak, where you have, the one or the type of air mass that's doing the pushing and the moving into the other. Stationary gets a little bit more confusing, or less, depending on how you think about it. Here with your stationary front, you're going to have a front that doesn't move very quickly because you'll have two air masses, cold air mass and warm air mass, that will literally kind of stall when they run into one another. Neither one may have the ability to push the other out of the way, so they'll just kind of hang out for a little while. This can bring some extended periods of cloudiness or even, precipitation. Occluded fronts, these are probably the most confusing, and we don't talk about them much more other than our presentation here. But here we have the combination of three air masses. You could have a cold, two colds in fact, as well as a warm. And the warm air mass kind of gets cut off from the ground and can create some extended periods of showers and thunderstorms depending on your time of year. So, folks, to recap, here air masses are again just large areas of air that has similar temperature, pressure, and humidity. And fronts will occur whenever those air masses collide. So now would be an awesome time to jot down any questions that you have for me, and come see me as soon as I'm available. So, adios until we meet again, folks.